In this example, we're going to look at solving equations using something called the square root property. But in part A, the first question we have is, what are we looking for when we solve the equation x squared equals 25? It's important to understand why we're solving an equation, what the ultimate goal is when we solve that equation, so that sometimes we don't need algebra, but we can simply reason through what the solutions might be. So when we are trying to solve the equation x squared equals 25, we're trying to find the values of x that will make this a true statement. In other words, what numbers can I substitute in place of x to make this a true statement? In part B, we'll solve the equation x squared equals 25 using the square root property. The square root property is exactly this idea, asking ourselves, what numbers could I square to get 25? Hopefully it jumps out at us that 5 is a solution for this equation. But if we stop and think about what it is we're trying to actually answer, what numbers could I square? What number could I multiply by itself and get 25? There is actually another answer. The other answer is -5. This equation actually has two solutions, because there are two separate values that I could square to get the result of 25. The square root property is essentially this idea, just reasoning out. I could square either a positive or a -5, and when I square it, the sign is going to get lost. The result of squaring a real number will always result in a non-negative answer. So we'll finish this off by simply stating the solution set is 5, -5. In general, the formal statement of the square root property is that if x squared equals k for some value k, then x is either equal to the square root of k or the negative square root of k. That's the square root property. This property does not rely on pure algebra, but it relies on logic. There are two numbers that I could square to end up with k, either a positive square root or a negative square root.